H2kinfosys provides world-class online IT training, staffing and software testing solutions to customers worldwide. H2kinfosys supports 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus. One-time pay, lifetime access to live classes and videos. H2kinfosys has won the trust of thousands of students worldwide. For free demo class, visit h2kinfosys.com.
So are you guys able to see my screen?
Yes.
Yeah.
Okay. So basically in SGF, the SGF is architecture based on the master slave architecture. So not only SGFS, all other architecture or distributed architecture works on the master slave architecture only. So we have one master and multiple slaves under it. So what will happen? Like if I take a general example of your life, master is like your manager, which is like a boss, which will tell you what you need to do, and it will basically distribute the work across their team members. It will not do any work, it will just keep track of the work, that yes, and it will continuously keep track of the work and continuously ask you for the status, master. So master is basic, and any request or any requirement basically goes through the master only, means the manager only. If any new request is coming to in your project, for example, and it will directly go to your manager, then the manager will analyze that requirement or something, and it will distribute the work, that this employees are free, so distribute the work across these employees, they will do. So master slave architecture is like that only. So master is basically the responsible for handling your request, whatever request you are getting from the client or from the outside world. So master will handle those requests and keep the track of the information of all the slave nodes, that what they are doing and how much the work they have completed. All this status and the information regarding the slave, the master is going to keep, and it is going to handle all those requests from the outside world. So master doesn't do any work, but it will just handle the request and keep the information regarding the slave nodes and the status of the work. But basically the real work is done by the slaves only. So the slaves are going to do all the work which has been provided by their master. This is basically master slave architecture. So if you're coming to the SGFS architecture, so in SGFS we have the name nodes and the data nodes. Okay, so name nodes are basically installed on the master. So name nodes are the master ones, and data nodes are basically the slave ones. So name nodes are installed on the master and data nodes are installed on the slave. Okay, so name nodes basically carry the information regarding the metadata. So when I will say metadata, it can contain the block IDs, the replication factor, the namespace. These kinds of information is handled by the name node. So basically it contains all the transaction history, that which file has been kept at where, which file has been deleted in SGFS, so path of the file, what is the replication factor for that particular file, what is the block, what are the block ID associated with that particular file. All these kinds of information is handled by the name node. Okay, and data node basically are the storage, and there the actual data is getting stored. So name node will provide the information, will give, if some request is coming, so name node will give that to this particular path you need to store the data, and the actual data is being stored at the data nodes only. And we can have multiple data nodes. And right now, previous to 2.0 release of Hadoop, we have only one name node, means one master and multiple data nodes. But but from release 2.0x, this has been changed, which I will explain today. So I think that's clarify your doubts, Shelja. If you have any other doubt, you can ask.
Yeah, I'm fine. And can you just give me just about the replicas, please?
Okay, so replicas. So actually, uh, in big data, we the fault tolerance, if I will go to this. So basically, if some file I am loading to the HDFS, if that particular file in a big cluster is getting lost, means it got corrupted somehow. So I don't have any mechanism to recover it from. I don't have any mechanism to recover it from the node. If it is had been corrupted, then if simply the file has, we have lost the file. So to uh, come up with the failure of this particular scenario, we have come with the concept of the replicas. So basically, in replicas, we create the multiple copies of a particular file while storing the file. Or after if, once the file has been uploaded, then also you can maintain the replicas of a particular file depending on the requirement. So basically, to come up with this scenario, if somehow instead of the file corruption, if somehow I have stored a file on node 1, take an example, my cluster is of size 4, 1 is master, 4 are the data nodes. So I have shown my file in the one data node number 2. First is the masters, second, third, fourth are the slaves. I have stored my file on the second node, and somehow the second node has been corrupted. Second node is not working and it is down right now. So now if some requests come for that particular file which is stored in the second number, so then how I'm going to serve those requests, how I'm going to process those requests, serve those requests to the client. So basically, we are not able to serve. So to come up with these kinds of failure, we maintain the replicas. We maintain the copy of those files of one particular file in our system. So you can set it to 2, 3, 4, depending on the requirement. Then how we need to decide? Basically, if we have a cluster, sorry. Basically, if we have a cluster, so before that, have you any idea about the um, rack, node, and cluster?
Yeah, yeah,
Yeah. So if basically we have two racks, okay. So in that, if so for first example, if we have one rack, so one copy will be saved in one node, and second copy will be saved in the another node. That's it. And if we have the two rack, one copy will be saved in one node of the rack, second copy will be saved in the same another node of the same rack, and the third copy will be saved in the another rack. So that's how the replication factor works. So basically, if taking an example of two racks, if one node got fails, it will check to the another node of the same rack. If both node get fails, it will go to the another rack and get the copy. So basically, by default, in some clusters we have the 3, in standalone we have the replication factor 1. That's how it works. To basically come up with the fault tolerance. How we achieve the fault tolerance, in basically this is the question which will be asked in some interviews. How we achieve the fault tolerance in Hadoop? Basically, with the help of the replication factor, we achieve the fault tolerance.
so the default application factor for any HDFS is 3.
No. Default, yeah. Default in clusters we maintain as a 3. If you will check the HDFS files, there you will find for the clusters, depending on the cluster how much size you are using, it will be 3. So you can maintain it while configuring and after configuring the SGFS. Like if you remember yesterday, I've shown you SGFS site.xml file. In that you can go and configure the replication factor. So by
Okay.
default it's 3. in cluster mode. Yesterday, if you have seen, it was 1 because that was in a standalone mode. It is set up.
Okay.
That was not a cluster because in that my master means the name node and my slave means the data nodes. Both are in the same machine. We are working. Okay. So any other question?
No, thank you.
Okay. So any other have any questions regarding the HDFS Hadoop? Because today we will complete the HDFS and start the pig, which is the another topic, and it basically it in that we will be able to process the data after getting the data into the HDFS. Okay, so I think we can start for today if nobody has any questions. Okay, so in HDFS architecture, what I have told you, it already get revised when I have told you that we have the name nodes and the data nodes. Okay, right now the architecture is like this. Sorry. So right now the architecture is like this. We have one name node and we can have n number of data nodes and we can scale it up according to our requirement, the number of nodes. So right now before 2.0, what is the single point of failure? Means the if one node fails, then the whole cluster will be down. So what is the name of that node? So if by chance a name node get fail previous to 2.0 version, then our full cluster will be down. Okay, so basically this we call a single point of failure in Hadoop previous to 2.0. What is the single point of failure in previous to 2.0 in Hadoop is the name node. If the name node fails, then the whole cluster will be down. Okay, is that clear? That why it's a single point of failure?
Yes.
Okay, so now to overcome this issue, what they have done in the next release in 2.0, so they have introduced like Okay, so what they have did that they have introduced one backup node, which we call a secondary name node. So one is active, one is passive. Okay, so sometimes they are called active and passive nodes. So sometimes they are called secondary name node, backup node. So they have introduced one backup node or secondary name node in the architecture. So basically, what will happen if somehow, so what backup node will do? So basically, it will whatever transactions are happening in this particular name node, whatever transactions. So it will at a particular time of interval, it is continuously take backup of that. Backup node will take continuously backup of all those transactions from the name node into its memory. So basically they become quite similar replicates of each other, name node and backup node. So, or you can say secondary name node. So in the right now, take an example, this particular name node is working and serving to all these data nodes, and this backup node is continuously taking backup, means taking a copy of all the transactions which are happening in the name node to its memory as well. And somehow if you somehow name node fails, now what will happen? So basically the transactions are already copied in the secondary name node or you can say in the backup node, and you can switch to this particular backup node. Okay, you can switch to the backup node and your single point, and then you will be able to overcome the single point of failure in Hadoop with the help of this node. For switching up to this backup node or secondary name node, it is not automatically. So right now it is automatically, but previous to that you need to do some manual configuration changes in the cluster to switch to this particular backup node. Okay, so as soon as the name node comes back, so it is going to serve, backup node is going to serve all the data nodes. So as soon as the name node comes up, the backup node will give all the transaction to the name node and again go into the passive state, just on the hold stage, you can say. It will just see the name node transactions and copy it to its memory. Any doubts? Anyone? I think it's no. See, if you have any doubt, you can ask in the session itself. Because if you take those doubts to the home, then it will be a problem for you only. Because here I can clarify. There, if you will search the internet or something, you might get something else if you have doubts. So we have one more node which we called HA node, or standby. HA node, HA means high standby node, we call it. So sometime what will happen, that the name node is not getting fail, but we are getting more requests from the expected one, that the name node is not able to handle more than that request. So for example, if we say the name node capacity to handle a request according to the configuration is it can handle only a 200 users request per time, it can serve around 200 only. So what will happen if the another request will come to the name node, like for one other request, 201 request will come to the name node. So basically in that scenario, it will not able to serve that request because its network and processing and memory, all those things are already busy, so that it will not be able to serve those requests. So in that case, that request will be rejected or something. So to overcome this scenario, what will happen? What they have created a HA node, which we call the high availability node. Basically, if some request means the name node feels that it needs help, or the traffic is getting increased to the name node. So basically, that particular traffic which is over that particular traffic which has crossed the threshold of the name node will route it towards the HA node, high availability node. So high availability node and the name node basically are connected to the same namespace. They will have the same namespace. Basically, they are not interlinked. So both name node and HA node are going to be connected to the same namespace. So same storage where we will have all the namespace common for both. So they can serve parallelly the request. So similarly, we can scale up the masters as well in the same way. Now in the current scenario, we can have name node 1, 2, 3. According to the requirement, we can increase, and similarly the data nodes also we can increase in the current scenario. Okay, so are these points which we have are clear? Because that's are important and going to be asked in the interviews as well. The secondary name node, high availability node, backup node, standby node, all this. Passive, active, passive nodes means same nodes and same concept with the different names they are going to ask.
So HA node comes into existence when a name node reaches its threshold point, right?
So yeah, if the traffic has been increased to some that configuration we need to do, then when we have to switch the request to the HA node. So that's the configuration that we can do in the HDFS. But yeah, definitely after that point that it is name node is not able to serve, it is busy basically. So when the name node is busy, it will check the cluster itself checked if first it will go to the name node only. If that name node is busy, so it will route that request to the HA node, high availability node, that it can serve as well. Why HA node can serve the same request as the name node serving? Because the name node and HA node both are connected to the same database. When I say the same database, they are accessing the same namespace and all. If any transaction is happening in the cluster, so they are going to store the transaction and edit logs in a particular same storage. They have the same storage. From there only they will get the information regarding this particular request, that where's the name node, block ID. They are going to do it from the same database only, same storage only. That's why they can serve in the same manner.
So the secondary node and the HA node, they are available by default?
No. As secondary node and HA node are not available by default. You need to configure it.
Okay,
So
and
you need to
earlier
give the
I
machine.
had asked, because my audio broke up, what will be the replication factor for the
Actually, your voice is again getting break. Your voice is not clear, Shelja.
Is it the same or
Shelly, I think you have a connectivity issue. You can type your question in chat. I will answer it. Okay, till that time, shall type a question. Anyone has any other doubt?
There is not a backup to the HA node, right? HA node is just by itself.
Yeah, there is not a backup for the HTML.
Okay.
So that's the question. Okay, that's what Aditi. So Shelja, replication factor is only for the data which we are saving. The data in basically what kind of data which they are storing right now, that's not the actual or user data which we are storing. So we don't create a replication factor of those things. And if I will say when I will say the master, so that's very critical. So we take the hardware configuration, RAM, memory, all these kinds of things. We take the means quality. We keep in mind the quality for the master, that it should be a good one, so it doesn't get failed very quickly, and we don't have that much amount of data or there, because only it has to serve many number of requests. So the when you will see, the memory of the master is quite good as compared to the data nodes, because it has to serve and the processing should be good, serve the request and processing should be good for the memory and the data which it holds. So that's not quite very large. That's why we don't give the replication factor. If you will read the HDFS documentation, there we have the concept of FS image and edit log. So basically, with the help of that, we can recover all the transactions if it get lost, with the help of the FS image and edit log. Okay, so that's why we don't have a replication factor concept in the master nodes. It is only related to the data nodes only. Okay, I think you all should read about the edit log FS image in HDFS, how it works. So I will just give a assignment that you all need to read about the HDFS concept, FS image, what is FS image in HDFS, and what is edit log in HDFS. So how it will work, how they come into picture, and what is the behavior of all these two, and why we use these two. Okay, so you can read it. Tomorrow I will have some questionnaire on that as well. Okay, so anyone has any other questions? Because HDFS is going to be finished today, because that's the last concept of the HDFS which I have told you, and all other parts have been covered. So any other doubt, questions regarding the HDFS, regarding the commands, regarding the architecture, or anything?
So regarding the backup node, will it activate only when the name node fails, or will it be active parallel along with the name node?
No. Only it will act when the name node gets failed. So we can call it as a passive node as well. So name node is going to be an active one. So every request and everything is going to be served by the active name node, the real name node, and the backup node will remain the passive one. It will just look to it that how all the transaction, all things It is going to look that and the copy that all this means all those transactions into its memory. Okay, into its memory in the backup node. So it will not be an active one until and unless the backup name node fails. So when the name node fails, then we can switch it to the backup node, because it has all the transaction, all things in its memory as we have in the name node. Only HA node can act in parallel, or we can say standby node can act in parallel with the name node. Backup node will not act.
Okay.
So anybody has any other doubt, or we can move to the another topic? Murli, Aditi, Vinay, anyone?
I think it's fine.
Yeah, I'm good.
Yeah, we can go ahead.
Shelja.
Okay.
Okay. You can read it, and if you have any doubt, you can ask me tomorrow. So now next topic will be pig. Okay. So let me open PPT. So right now we have covered the HDFS, okay, and we need to cover these two as well, but okay. And so in scope we will have these two: YARN, HDFS, Flume, Sqoop, Pig, and Hive and Spark. Okay, so HDFS is finished right now, and we are going to use HDFS only for storage in our full training. Only HDFS we are going to use as a storage. The final destination where you will dump your data is HDFS. So I will skip the YARN for time being. Why? Because it is again a theoretical part. Only pure theory is there in YARN. So I will give some practical use cases. Want to give some practical use cases to you as well. So for that I am using Pig on top of it. So if you know that everything in SGF in Hadoop is run on the mappers and reducers. So basically mappers and reduce. So I'm telling you why this Pig and Hive and this Pig Hive came into picture in Hadoop. So basically previous to these we have only mappers and reducers. So mappers and reducers are basically are based on the Java. So if anyone knows Java, then only they will be able to do work in the Hadoop with the help of the mappers and reducers. So so for any logic they need to write a Java code, and that Java code works in the Hadoop. Okay, so previous to Pig and Hive, only mappers and reducers are your option to work in the Hadoop. To process your data, all is the mappers and reducers. Still we have the mappers and reducers, but how the technology has evolved, what they have did, that on the top of the mappers and reducers they have given another language, Pig, which is a scripting language. So basically you write your code, or you write the script in the pig language, which we call the pig Latin, and that particular language is going to be compiled or converted into the mappers and reducers itself, and in the end the mappers and reducers are going to be run in the pig, in this pig language as well. So instead of concentrating on the programming language, that's why Hadoop can be learned by anyone, because in that you don't need a programming background, hardcore programming background. You don't need. If you have some knowledge or you have a gist to learn this, you can learn it in pig. So basically you more concern, you can just write the scripting language, and that scripting language can be converted back to the MapReduce itself by the pig compiler. So it will be automatically converted, and the mappers and reducers will run in the background. They will do your work and you will get the output. So it was originally developed by the Yahoo pig, and the reason and the thought behind for developing this is like they need to analyze a huge amount of data. Okay, so for analyzing the huge amount of data, they want their resources or the employees to more concentrate on the analyzing of data instead of checking the code, or uh, instead of checking the code and writing the code and all those things. Like if you are writing Java program, you need to know about the Java, you need to concentrate that all the syntax will be correct like this. In this as well, the syntaxes should be correct, but in that the language, when I will show you, the language is so easy that anyone can write it. It is just like a simple English language. Means if you like in English you write, I want to filter this, I want to filter this from this, I want to join these two things, I want something out of like that, only you can do in a pig scripting language. Okay, so it was originally developed by Yahoo, and reason behind of the development is basically they want to do some analytics on the large amount of data. So they want their employees to be concentrated. They should concentrate on the analytics instead of the language which they are using. So they have developed that. And if you, I will compare it with the mapper and reducers. Map and reduce basically with the Java code. I'm saying when I will say mappers and reducers, so in that you need to use Java only. So mapper and reducers have one architecture, have one concept, but that concept work with the Java only, Java language. So we are definitely going to learn about the mappers and reducers, their architecture. We will do some hands-on on Java, some hands-on on program as well, but we will not go in that deep because we need to learn the Java in the end otherwise. So if you write a mapper and reducers, so basically that line of code will become so hectic that you need to write around, if you are writing the 100 lines in Java to do some programming or achieve some processing or analysis in mapper and reducers, so that code can be written in pig in a 10 line or 15 line, max to max 20 lines. I'm saying in max to max 20 lines that code will get finished. So 100 line of codes one place you have, and you have 20 line of codes only to complete the same task. So that's also the reason the pig came into the picture. And the handling of the unstructured data in Java, you can do anything. Basically in Java you can handle any kind of data, but in pig, when I will say, so pig is basically used to handle large amount of data and to handle the unstructured data in a more efficient way, like we have. So in that we have already inbuilt classes, inbuilt functions to handle this structured data. Oh, sorry, unstructured data like XML, JSON, all these kinds of data. Okay, so that's a small introduction about the pig. So which language basically we use in pig is the pig Latin, which we call. Okay, so pig Latin is the language which is getting used in pig scripting. So I have told you a link as well. Did anybody get a chance to look at that Pig Latin language manual?
Yes.
Yeah, I tried looking at it.
Okay, that's it. So frankly speaking, right now pig demand of pig in the market uh, is quite low as compared to the Hive and Spark. Okay, only reason why we are studying pig if the demand is low, you will be thinking about that. Only reason we are studying the pig because pig is the initial one which is getting first is the MapReduce which came into picture when I started. Mappers and reducers were there, then the pig came, and it has vanished very quickly. Then the Hive has quite a good demand in the market. If you know Hive, you can work on many other cloud infrastructure as well if you know Hive. And after that the Spark, which is the booming one right now, Apache Spark. So basically we will not that much concentrate. We will learn the pig, but we will not go that much deep in pig. So because when you go for the interview and you have written pig as well, then they are just going to ask you some basic questions about the pig only, or they will ask you the difference between Hive and pig when you are going to use the pig, like this kinds of question they will ask. And they will ask some basic question: how to load the data in pig, how you can filter, what are tuples. So very basic question they will ask in pig. So that's why I also will not go that much deep in pig. If you want, I can go, but I am going only as per the interview point of view and what is going in the market right now. So right now we will go to the every function of the pig. You can practice it, you can ask if you want, means you can ask if you have any doubts. But this session I will finish it quite quickly in pig. But on Hive we need to do some thorough study because Hive is in demand and it's quite easy. It don't have any programming language or something. It has only SQL if somebody has work. That is easy. You can do that as well. So Pig. In Pig, we have we have the language that we call the Pig Latin language. So you can go through this manual. Okay, so you can go through this manual. In that, you have the example as well. How this example are working. I will make you show. Yeah, I will show you all these examples for each and every function as well. Okay. Yeah. So pig we have the language used for the pig is the Pig Latin language, which we call, and it is an operator based language basically. When I will say operator based language, it is basically like operators which we have like equal, okay, like equal and many other operator we have. So basically in this we have relations. Four four terms comes into picture in pig. First is relation, then we have bag, then we have tuples, then we have fields. Okay, let me show you what is relation. Then so basically if you write something like this and I have assigned this to this every line is basically a relation in pig, if I will say. Okay, relation is basically a bag. Okay, you can write it down, you will not find relation is basically how we are relating the things or how we are computing the things in the pig in a particular syntax or in a particular line, in a particular syntax of a line, how we are relating the things. So in that, this particular line emp is a relation. So with the help of this syntax we have related some things and we have created a relation emp with the help of this syntax. So relation is particularly bag. And what is a bag? Bag is basically a collection of tuples. Okay, bag is basically a collection of tuples. Okay, what are tuples? Tuple is basically a collection of field. If I will go more deeper, and what is field? Field is basically a data, piece of data. Okay, so starting from the first, what is the relation? Relation is basically a bag. Bag is a collection of tuples, and tuple is a collection of fields, and field is basically a piece of data which we are using. Any question?
So tuple is a collection of fields, right?
Yeah. So when I will say collection of fields, and field is basically a piece of data. So eventually it will become, tuple will become a collection of data.
Okay.
Yeah. So till now it's clear about the what is big, what are the fields which we are, what are the fields which we are using in field, going to use in the field, what are the terms we are going to use in the pig, and how the pig has been originated. Till now it's something you have got about the pig, that how it came into picture, how we are going to use it. Okay, I think it's clear. So let me start. Okay, so in this we have the relation, tuples, and all those kind of things. I understand this will be new to you, but you will get to know about these things, the tuples and all. So for tuples, basically we define the tuple with these two symbols. Okay, so in this we have one field, field 1, 2.
Is field a collection of data or a piece of data?
Basically a piece of data. Like we have, if I will take example,
So the piece of data, does it have any size limitation?
size limitation piece of data. So basically it depends on the type which you have to choose. Like for the byte, int, string, depending on that, the piece of data size will depend, limitation will depend. Okay, so right now if you are seeing like the piece of data, you can save the whole text file as well. in that particular data, because that's the particularly unstructured. Pig is for the unstructured one. So basically you don't need to have only one field or something like that. You can have like for example, you can have full file as well there, depending on the type of that particular data in Pig. So the limitations, if you are going to check that the types of the data in this particular data types and more. So 1 minute, you have one table and you will get that the limitations of everything. See, int sign 32-bit integer, example 10, 64-bit, like this. These are the types which you can store. Okay. Yes, no. So if you will see, the by default type is the byte array in Pig. So that's a blob. Blob means long strings we have. It can contain the long strings, means as such limitation is not there, but it can contain the large string as well. Means I have what I was saying, that you can store a full file as a data field as well in this particular tuple. Okay. Is it clear or
Yes.
any other doubt? Because in this it is all purely unstructured data. That's why I have opened this Excel to show you this. So how conventionally we get in the database? Okay, so conventionally in structured database or in database, how we get data, we have some columns, and against the columns we have some data. So name is Rahul, age is 18, location is India. Similarly, what's the name? Name is Vinay, age is 21, location is Canada. So in this kind of in this format we get the data. In this format we get the data in the databases that we call the structured data. So if you consider, if I will take this, basically data here, it is Rahul, 18, and India. So what will the tuple look like in Pig? It will be like how? Rahul, 18, India. So that's a tuple, one tuple. And Vinay, 21, Canada. That's the another tuple. So right now, if I will explain what is this particular thing, that's a tuple. And now what is tuple? Collection of fields. Here what are the fields? This data. So are you getting what I'm trying to say? So basically this is the tuple, collection of data which we have, piece of data. Okay.
So each tuple will have some relational fields between them.
Each tuple will have a relational fields between them. They can have a relational fields, or they can have a relation. Yes. Or sometimes you will not be able to.
Is there a limit to how many fields or no?
No, right now if you see tuple field n, means till n we can go.
Okay.
And in tuple, they can have relations, or there might be possibility they don't have any relation, because that's not the structured one I'm saying.
Okay.
Because a relational we will find in the RDBMS database, the structured database, they have the relations. So might be there is possibility we have some field which don't have any relation with the another field. That's why we call the unstructured. We process here the unstructured. So right now it is I'm giving you the RDBMS because in that you will always have some relations. Each column has some relations. So if you will see this particular collection of data is the you will have tuple, and now collection of tuple what we call bag. So bag look like this. Okay. When I will enclose in the curly braces, this will become a bag, which is a collection of tuples. Getting my point? And when I will give some, and it has some relation, that why it is called a bag. This particular syntax of bag and relations are quite similar. So that we called a relation as well in pig, and it is a bag as well. So did you get what I explained here, that how the tuples are getting formed from the relational point of view, relational database point of view, that what is bag and what is tuple and what are the fields? Okay. Yeah, if anybody has any doubt.
I think it's clear.
I'm good.
Okay, so right now if I will go to the relational database, you will find that the number of elements or fields in the tuple will be same, right or wrong? So when I will go again, if I create one more entry and I will write current so again it is going to have the same number of fields, correct? So in relational, when I will say it can have the it in relational database it will have the same number of fields, but in case of the tuples, okay, in pig it is not mandatory that each tuple should have the same number of fields, right? So it can contain another extra field and address. Like this, it can have one extra field. That's not the limitation for pig, so it can have an extra field. It is not mandatory that each tuple should have the equal number of fields inside that. Okay. Okay. So that we have for today. So you can, that's are just the basics. So tomorrow what we are going to do. Tomorrow we are going to do this up. This is basically a scripting. This is basically a script. This we will practice in Hadoop in Pig. So that we will do. So anybody has any question you can ask. Otherwise we can wrap up this session. Tomorrow will be the practice section for this. So anybody has any questions?
So how do you practice that? Like, we didn't set up any environment for the Hadoop.
Yeah, that's for that thing. I am in conversation with the management, so we'll let you know. We'll try to get the environment to you guys as soon as possible. If we'll try to get the environment as soon as possible, because I'm in conversation with the management. They are checking it out how we can provide the environment to you guys.
Okay.
So definitely they will provide. I will make sure that you will get your environments, because that's mandatory from my point of view. I always, without environment, it's quite impossible for me as well to train you guys, because in the end, the practical will come more handy as compared to the theoretical part. You will get more clarity on the topics when you will do yourself. So, any other question?
Able to email you
Sorry?
in
Hello?
case we have any doubts in between. Will we be able to email you?
Yeah, you can ask me. Not a problem. You can ask me directly if you have any doubts. Or what we can do, if somebody has any doubts, they can wait in this call itself after the session. When I will finish, they can wait in this call only, and we can clarify doubts one-to-one in this call. If you email me, that also I can reply, not a problem. If you want to ask in these sessions only, after the completion of this session only, we can wait and clarify the doubts one-to-one. Both will be fine for me.